Hello everyone, welcome to the first lesson for topic 1, which is forces and equilibrium. So this is also the second topic now because we kind of like reshuffle the topics in the M1 syllabus, right? Okay, so in the previous chapter we learned about kinematics, so which means that the motion of the particle. So starting from this chapter, we are going to look at what causes the motion. Okay, so which means we are going to look at the forces and also equilibrium in this state. Okay, so for the first lesson, it's just going to be like a very easy one. So meaning it's not going to involve any formula yet. So basically, we are talking about the basic nature of forces. How do you draw a force diagram? Then if let's say you have more than one force, how are we going to find the components and also the resultant of the force? Okay, so you are going to use a lot of calculation which involving trigonometry that we have learned before. So before we move into the part where we discuss about force, we'll do a very quick recap on the Pythagoras theorem, the sine rule and the cosine rule. Then we'll talk about the force and then the resultant, and then we'll end with components and also some past year questions. All right, so let's start with the quick recap. Alright, so just go through it like pretty fast. So yeah, for Pythagoras theorem and normal trigonometry that involves sine, cos, tangent, right? Then we'll use it in a right angle triangle. So in this case, we know that for a relationship for all the side, then we will have the hypotenuse. So if let's say this is C, this is A, and this is B. So for the Pythagoras theorem, we know that C square will be equal to A square plus B square. Okay, so for sine cos tangent, then we have that if let's say our theta is here, so which means our sine theta will be equal to opposite divided by hypotenuse. Then after that, cos theta will be equal to the adjacent over the hypotenuse, and the tangent will be equal to the opposite over adjacent. Okay, so please bear in mind that for the theta, it actually give different adjacent and opposite when you change the theta. Okay, so what you need to remember is just that adjacent is the side that is in the middle of the angle and also the 90 degrees. So if let's say the theta is here, which means your A will eventually come here. Okay, then for non-right angle triangle, meaning for all triangle, we can use these two rules, so which is the sine rule and cos rule. So we try to use sine rule if you are given a pair of angle and side, then what you want to find is in a pair also. Okay, so which means in this case we can see that we have 42 and 3.2, so which means that we can always write it in 3.2 over sine 42. Okay, will be just equal to, so B is what we want to find, for example, so it's B over sine 58. Okay, so this is in a pair, this is in a pair. So which means if let's say we want to find another equation, right, then it's the same thing also, then it will be A over sine A. So normally we are going to choose either one part lah, because we are not going to write it in like this form, right? So whichever two pair that you have, then you can form a equation already. Okay, so that's the idea. So this is a fraction, so that's why you can always just turn it around. So which means so normally my way of doing it is that if let's say I want to find the length, then I'll try to put the length at the numerator part. If I'm going to find the angle, then I'm going to put the sine angle at the at the numerator part. Okay, so depends on which way that you prefer, but basically you are just getting the same answer. Okay, so for cosine rule, so this is the rule that help you to check either you have two sides, one included angle, and you want to solve for the side, or you have three sides and you want to solve for the angle. Okay, so in this case, the cosine rule tells us that c square will be actually equal to a square plus b square minus 2ab then cos c. Okay, so the idea is that this is the side that we want to find. So that's why we have 9.5 and 4.2 and one included angle. Then the side that we find is the one that opposite lah, is the one that you do not have basically. Okay, so in this case, the idea is that c square will be equal to 9.5 square plus 4.2 square and then minus 2 times 9.5 times 4.2 and then cos 37. Okay, So I hope that you are very familiar with all this formula already, not by memorizing the ABCD. So eventually, if let's say we try to change the unknown, then you also know what to do. Okay, so yeah, so remember all this, and these are the things that we are going to use later. So let's start with the content of today's. So the introduction for force. So a force is an influence that can cause a change in the motion of a body. Okay, so a change in the motion, which means that, for example, if without force, then an object will just remain stationary or it will just keep on moving with a constant velocity. Okay, so that's the idea of it. So in our daily life, normally we will recognize the concept of force as a push or as a pull. So meaning, for example, when you try to push a trolley or you try to pull a trolley, you are actually causing a change in the motion of the trolley. Okay, so yeah, that's what force is. Okay, so before we look at some situation that's given, right? So yeah, just take note that in our mechanics one, when we are trying to modeling force, right, we only consider about the part where there's translation involved for the motion. Okay, so let me try to explain it like this. So normally we will try to model as the object is just a particle. So as what you learn in chemistry or physics, so we know that particle is just a very tiny thing, right? So we are looking at it like just a dot. It's like a 2D thing. So the motion that we are looking at is that how it move. You get what I mean? Like how it move. Okay, so which there's no involve of rotation. So which means that we are not viewing it like as an rigid object that is going to rotate itself and so on. Okay, and there's no deformation also. So which mean, for example, deformation would be something like this is like an object that after you push it or pull it like a table tennis ball, then the ball isn't going into be like going in something like that. Okay, so give you a simple example is that if let's say when we are talking about we try to kick a ball, okay, so there's a force that actually applied on the football, right? So when we talk about you are kicking a ball, we only consider about the distance, the motion, the translation of the ball only. We don't consider about whether your kick actually make the ball rotate or not, or it actually make the ball deform at the instant where you kick the ball. Then after that, it goes back to the original size and so on. So we are not taking into consideration for these two things. So which means that we only look at it as if it's a dot, it's like a very tiny particle. So that's why there's only translation that happen. It's like a 2D plan only. Okay, so that's the idea. Okay, so now we move into the part where we want to discuss today, which is resultant. Alright, so as what we have mentioned just now, so we know that force as if like what caused the motion, right? Then it is always recognized as a push or a pull. So that's why force is a vector quantity. So it has both magnitude and direction. So yeah, for example, the magnitude, which means it talks about like how what is the force, like how hard you push or how hard you pull lah. Yeah, then the direction tell me, yeah, so you can imagine if let's say when you try to push something or you try to pull something, then the direction will be different, right? Yeah. So the magnitude of force is measured in the unit of Newton. Okay, so yeah, today we are not going to look at the formula for Newton yet. It's basically about you are given like a situation for force, then you will know how to draw the force diagram and also how to resolve the force and how to find the resultant. So at this place, we are going to talk about the resultant first. So why do we need a resultant is that in real life context, in most of the cases, right, we imagine that there will be more than one force that actually involved in a situation. So yeah, for example, when you try to look at something, right, simple as when you are trying to push the trolley, actually there are forces that actually apply from the weight of the trolley. And also, how about the friction? Then the force that you apply when you try to push it. So you can see that it's not about how many person that trying to apply the force. It's also about the environment that you are in and the object that you are actually pushing or pulling. So all the forces will then be combined and that form the resultant. And this is at the end the final forces that actually causes the motion. Okay, So to find the resultant force, in this case, we are only talking about two forces. So later you will realize that there's a limitation for this then, so that's why we need to learn how to resolve it in component. Okay, so to find the resultant force, we can use the idea that we have learned previously in vector. Yeah, so don't worry about that. It's not so much, it's just the idea, the concept of it. Okay, so what we can try to do is that first one is by using the triangle rule. So in the triangle rule, as if that we can try to imagine if let's say this is our F1, okay, so this is our force 1. So we are trying to place the start of our second force at the end of the first one. So this is our first force, right? The direction going up. So this is where it ends. So you start your second force after the end for the first force. Okay, and the resultant will be the one that connecting the starting from your first force and the ending for your second force. So this is how you get your resultant. Okay, so which means that in terms of vector, then we know that you can actually just solve r equal to f1 plus f2 lah. But please bear in mind that in all our questions here, right, our force we are given a magnitude and also the angle. So angle tells the direction, and then the force here tells us about the magnitude. It's not like vector that you have everything in the equation already. So make sure that you don't find your r by, like for example, f1 is 5, then f2 is 5. So you cannot do r equals to 5 plus 5. Yeah, I hope that you get what I mean, because that only possible if let's say 5 and 5 is like in the vector form. Okay, so which included both magnitude and direction. So in this case, it's not the case. Okay, so the second one is by using parallelogram rule. So it's actually more or less the same with the triangle rules. Let me try to show you, then you'll understand why. Okay, so the idea is you try to place both forces with the same starting point. So this is a starting point, right? So this is your first force, and after that, this is your second force. Okay, so when you are trying to apply these two force, then you can actually imagine that the resultant force will just in the middle. So after that, you try to draw a parallelogram. So it's the same thing, like this will be the resultant as well. So you can try to imagine if let's say, oh, when we talk about vector, right, we can always move it around. So this is the F2 thing. So if let's say I try to move it here, right, you will see I get the exactly same thing like triangle rule. So that's why it's just the same thing. Okay, but in terms of whether which one is easier, then I'll always encourage you to go with triangle rule. Yeah, but don't worry about this part. What is more important is after we learn the component. Yeah, so this is like an idea for you for resultant only. Okay, so let's look at the example here. Okay, number one, an anchor is being pulled using ropes by two sailors for the, yeah, with the force of 14 Newton and 16 Newton as shown in this diagram. So the angle between these two forces is 60. So the question one is to find the magnitude and the direction of the resultant of the two forces. Okay, so how are we going to do that? So we are trying to apply the triangle rule that we know. Okay, so since that this is our 40, so for an easier one is we try to move the 60. So what you can try to do is you try to draw the triangle out first. Okay, so this is our 14 Newton. All right, so what we are trying to do is we try to move the 60. So you still remember, so where it ends for your first force is where you start for your second force. So it's going to look like this. So it's going down. So it's 460. Okay, then after that, your resultant will be the one that you connect the edge together. So this is your resultant. All right, so this is the idea. So the question wants us to find the magnitude and the direction of the resultant of the two forces. So which means that we might need to find what is the angle over here. Okay, so this is the resultant. So don't worry about the direction, which means that, for example, if let's say you try to move the 40 over there, right, then it will be another way for you to write the angle. So it is actually an objective thing. It's not like a certain answer, the number only, because you need to describe how is the angle move later. Okay, so let's try to find the resultant first. I guess that will be easy. Okay, so you see that it's given 30 degree here, right? So we might need that angle here as well. So that's why you can try to imagine if let's say I try to expand it here, right? Then actually where is my 30? The 30 is actually here. Am I right? So this is my 60. So if let's say I try to, so this is what I did in my picture here, right? So I try to extend it here, so this become my 40. Or it's the same thing, or I try to move it here lah, then you can see that like 60, 60 is parallel. So that's why we know that here is going to be the 30 that happens here. So that's why this is a part where I have 150. Okay, so now I can continue to solve it. So by solving my r here, then I can actually use cosine rule because I have two sides with one included angle. All right, so which means r squared will be equal to 40 squared plus 60 squared minus 2 times 40 times 60 and then cos 150. Okay, and you'll be able to actually get the answer for 9356.92 and so on. So remember to press everything in your calculator using the exact value, okay? So 96.7312. Yeah, I'm writing in more decimal places that later to avoid the cases where later I might need to use this information. So that's why I cannot use the rounded off in three significant figure one. So this is what you need to be careful of when you try to do this type of question. Okay, so now we solve our resultant already. So now is the angle that we want to find. So how can I do this? So you can imagine that it's either you want to do cosine rule again, or an easier way is that since you already have 150 and r, right? So you have the opposite side for the angle that you want to find also. So that's why we can just use sine rule. So sine theta, okay, is actually opposite of 60. Then equal to the other pair will be the sine 150. So you see, this is why I involved the r here already. So that's why make sure that you are trying to use the original value, or if not, then at least the value that at least I mean more significant figure than the number that you round off. Alright, so after you try to solve in your calculator and you'll be able to get 18.1 degree. So you must remember when you try to indicate the direction, you must indicate 18.1 from where, because this is the diagram that actually you draw by yourself. So you can try to imagine that what happened here is your resultant is actually below the 40, right? So that's why it's 100, that's why it's 18.1 degree. So you are going down, so that's why it's a direction of clockwise. Okay, clockwise from the direction of the 40 degree. Okay, from the direction of the 40 Newton, sorry, of 40 Newton. Okay, so make sure that in every question that involve angle, this is how you should answer. Because if not right, you can imagine if what happened is if I try to use the other diagram, then my the angle that I found might be the angle that, so what you are finding is actually here. So here is like 18.1. So you imagine if I try to use another diagram, then I might be actually find my answer here. So for this answer, then eventually is going to give me another answer. So in that case, then how am I going to answer? So for example, if let's say I get, so is 30 here, right? So 18 is around 12. So for example, if let's say I get my 12 here, then it will be 12 Newton anti-clockwise from the direction of 60 Newton. Okay, so that's the idea of how you should write it. Okay, so now example 2. Alright, number 2. So this is a diagram of a boat that actually being pulled by these horses. So there's stronger horses that give 300 Newton force. Then after that, the other one produce a force of 260. Okay, so question 1 is to find the acute angle between the two forces if their resultant has a magnitude of 540. Okay, so similar with the question before, so but then it's just that now we are given the resultant and you need to find the angle. Okay, so how are we going to do that? Let's do the same thing. So this is our first force, so that's why we can try to draw that first. So this is our first force of 300. Okay, then I'm going to place this second force after my first force. So it's going to be something like this. So this is my 260 Newton. Alright, so now what happened is that I have this resultant. So from here to here, sorry, let me try to redraw it a bit. Yeah, so I have this resultant that goes like this. Yeah, so this is my R. So the question actually want me to find the acute angle between these two forces. So this is my two forces, right? So from here then you can obviously see that this is always going to give me an obtuse angle. So for me to find the acute angle, this is first force, second force. So the acute angle actually happened here. Okay, which means for example, if let's say I try to extend this, or it's the same thing also if let's say I try to draw the other place lah. For example, I try to extend it over here. So this will be my acute angle. Okay, you get what I mean? Because when I extend here or I extend here, it's just going to be 180 minus lah basically. So the idea is just the same. Okay, so now what I can try to do is I try to find the angle inside first. Okay, then after that I use 180 to minus, then I'll be able to get the acute angle. Okay, so now then I will need to use cosine rule because for the R here, then I have my 540, right? So it's like given three sides and I need to find the angle. So in this case, then it will be helpful for us to actually transform the formula first. So we have a square equal to b square plus c square minus 2bc cos theta. Okay, so imagine you try to bring the whole thing over here, then you try to leave your equation with cos theta only at the left hand side. So cos theta will be equal to, so moving this to the left and a square to the right, so b square plus c square minus a square, then this one go down become positive already, right? So divide 2bc. Okay, and a should be the side that opposite of your theta, so in this case it will be 540. So cos theta will be equal to, so b square, so that's why it's going to be 300 square plus 260 square minus 540 square. Okay, divide by 2bc, so 2bc. Okay, so after you solve it, then you'll be able to get 149.2. All right, so make sure you have this answer because we not try to get the acute angle, right? So the acute angle between the two places will be equal to 180 minus 149.2, which will give us the final answer 30.8. So in this case, you don't need to write the direction lah because the question already give you that they want the acute angle. Alright, so now let's try to look at the next part, which I will say is the most important part in this lesson. Okay, so this is the parts about components. So previously we know that we learned how to actually combine the two forces into one resultant force, right? So however you would have realized that, so it might be very difficult if let's say if I have more than two forces, then am I going to find the resultant for the first two, then after that I add in the other one and do a continuous work after that. So that's why in this case we're trying to look at the other process, which is how are we going to take a single force, then after that we try to break it into component. Okay, so yeah, don't worry about the understanding part. Later when we try to do the question, then you will understand why is that. So you might wondering because previously we talked about combine the forces, then isn't it now if let's say I try to resolve the force then break it into two components, then isn't it will make it like uh it will make your original element become like much more. Yeah, but the idea is that after we try to break it into two fixed component, then we are going to use that two fixed component to actually find our resultant. Okay, so in this process we are going to learn how to resolve the force into two component in perpendicular direction. So normally in our questions, the direction that we will be using is like the x-axis direction and the y-axis direction lah. Okay, so how do we do that to be exact? Let's try to look at this diagram. So for us to resolve a force in two perpendicular directions, so for example, this is our resultant force, right? So our objective is to resolve it in two perpendicular direction, which means one direction is the x-axis direction and the other one is like the y-axis direction. Okay, so imagine what happened here is the component that I have here, right? Basically, it's just the same thing if I try to move it over here. So that's why you can see that it will eventually form a right angle triangle there. So that's why if let's say I have the angle theta here, so if it's in this right angle triangle, right, then I can always write that the cos theta is actually will be equal to my a over h, right? So where is my a in this case? Then it will be the length here, right? So which is my component, my resolved component for my x direction. So that's OX here. Okay, so I'm using like OF, then over my hypotenuse, which is F. So in other words, my horizontal component here is actually F cos theta. Is that okay? So which means I am given the force and I'm given the theta here. So for me to find the force in the component of x-axis, then which means it will be equal to F cos theta. So in the other case, then if let's say I want to find the y here, which means it's going to be the opposite and the hypotenuse, right? So that's why I can use sine. So for sine, it will be equal to this part is my OY. Okay, because this length is basically the length of here. So over the hypotenuse as well, which is F. Okay, so I can always write OY is equal to F sine theta. Okay, so it is important for you to be able to actually use this formula and this formula without having to every time you need to write cos equal to AH and sine equals to OH, because it will take you a lot of time on that. Okay, so that's why let's try to talk about a shortcut here. So what you can imagine is that for cos, right, you always use the adjacent and also the hypotenuse. So for hypotenuse, that's the one that you don't need to think already, because hypotenuse will always be your resultant. So the idea is, if the hypotenuse isn't your resultant, then normally it will be on the x-axis or y-axis, then you don't need to do any cos or sine already, you get what I mean? So that's why your hypotenuse will always be F. Then the adjacent will be the one that the angle touches rather than the force, right? So whenever that you want to find a component that the angle touches, then which means you will do F cos theta. So you just remember this one is the one when you want to find the length which touches the theta. So for y, right, you imagine that this is why you use sine because of its opposite and hypotenuse. So same thing, hypotenuse is not going to change. So for your opposite, right, is going to be the one length that actually your theta wouldn't touch it. So that's why whenever you see that you are finding a length of a side that the theta didn't touch, so you will be using sine theta. Okay, so I hope that you roughly get what I mean, but don't worry about that. We are going to do one very quick example before we move on to the partial question later. Okay, so yeah, I mean, in the other hand, so we know that the force in the x direction will be called as the horizontal component, and the y direction will be called as the vertical component. So you can imagine, no matter how many force that we have, right, after we try to all change it to the horizontal component and the vertical component, so by having these two components, then we can always find the resultant by using Pythagoras theorem. Because it's just the same thing, like we have this line and this line, then we can find the final resultant already. So like the horizontal component, the vertical component, so we can get the resultant. Okay, so that's the idea. Okay, so now let's try to look at the first example first, so to let you understand how to use this like in a very easy way before we move on to the puzzle question. All right, so example 3. So this is a basic skill question which I want to use it to explain to you guys before we move on to the further question. So yeah, using the diagram and find the components of the given force in the direction of x-axis and y-axis. So you are given the force of 6 Newton here. So what you need to do is break it into two components in the direction of x and in the direction of y. And you are given the theta here is 20. Okay, so before we move on to the right way, right, I just want to state that please do not remember it as if let's say you want to find component in x, then you use cos. Then if you want to find component in y, then you use sine. So please do not think like that, because you will have a problem if let's say I change the angle that given to you. And if let's say this diagram is not given nicely like this, so for example, if what I want to resolve in this direction then you will have a trouble in where is your x and where is your y. And this idea is not correct if let's say my 20 is not given at this point. Okay, later I'm going to explain to you why is that so, but let's try to do the right way first. Okay, so like what I mentioned just now, so in this case, meaning that this will be our resolve x, right? So we'll try to resolve it in the x component. Okay, so make it a habit that we always write down where is our direction as positive. So in this case, maybe you try to make it easier, we'll try to do to the right hand side is positive. Okay, so this is the sign to actually remind ourselves. Okay, so this is the resolve that you want to find, right? So now this line is actually touching the 20-degree here. So that's why for touches the angle, then we will use cos. So that's why 6 cos 20. Is it okay? All right, so now we move on to y. So for y, the same thing. We try to assign that going up is the positive direction. So this is our ry. Okay, so when you look at this, then you know that 20 is actually not touching this line that you want to find, right? So that's why if you can imagine when you try to move it over here, then this will eventually become your hypotenuse already. So that's why the resolve to y is become 6 sine 20 because the 20 is not touching the line. Okay, so now I'm going to explain why I tell you that do not remember it as if x use cos then y use sine is that. For example, if let's say I try to change my 70 over here, let me try to use the other color. Okay, I try to change my 70. So if let's say I'm not given 20 here, I'm giving you 70 over this side. So my question to you is, do you still think that Rx is going to give you 6 cos 70? It's not going to be correct, right? Because you imagine your 70 is here. When you try to put your Rx up there, right, this is actually your opposite. It's not your adjacent anymore. So that's why you should use sine. So that's why I said you do not remember as if cos or as if you want to find x, then you use cos. So the idea is if you are using the touches or not touches, then by looking at this, then you know that you see, you want to find Rx. Rx did not touch the 70, right? So that's why it's the opposite. So in this case, Rx is also equal when you try to do 6 sine 70. So you can try to use your calculator, it will just give you the same answer. So similarly, when you try to look at y here, so although you are finding y, but you cannot always do sine because now 70 is touches this line. So that's why we try to do 6 cos 70. And these two will just give you the same value. Okay, so I hope that you understand how the whole thing works. So basically, you just remember that if you want to find the resultant that this angle touches, so like you have the forces, then after that, this is like the adjacent where the angle touches. So that's why you are doing cos. So if the angle that given to you is not touching your line, the component that you are finding, so which means your component will eventually be the opposite. So that's why you are using sine. Okay, so yeah, so that's the idea. So now I hope that you can understand this thing first before we move on. So now let's try to look at the puzzle question number 4 here. Okay, example number 4. Yeah, so this is like a level 1 question, so like a very basic one for you to understand how do you use resolve to actually find the resultant. Okay, so yeah, a boat is being pulled along the river by these two person on like at the two side of the river last. So the first person is actually giving forces of 16 Newton at angle of 25 to the direction of the river here. Then this is another person, okay, by looking at this diagram. So number 1, they want to find the total force that actually applied by the two people in the direction of the river. So which means the direction of the river is here. Okay, so which means what we need to do is actually just resolve it in the direction of the river. Then after that, we try to plus them together, or if you need to minus and so on, just try to find the total force. Okay, so number 1, to find the total force in the direction, which means that we want to find the force in the direction of the x here, right? So that's why we are resolving it into the x-axis direction. So in this case, same thing. So since this is the direction of the river, then you can see that the direction of the pulling is actually here and here, right? So you can imagine that the outcome the answer, the direction would be in this direction more than that direction. So that's why we try to just make our right hand side to be positive. Okay, so it will be equal to, so by looking at this, I hope that you can straight away get that this is going to be 60 cos 25. Okay, because what you want to find is touching the 25 here, then after that the other one 50 go up also is the same thing, right? So imagine this is a right angle triangle, then AH as well. So that's why plus 50 cos 15. Okay, so yeah, just like that. So you might have a question that isn't this in another direction? So do I need to do minus? So the idea is when we try to resolve it into this into the x-axis, right? So we are looking at both these two is actually moving to the right hand side. So that's why these two forces should plus together. So the idea is if let's say I have the other person here which is pulling in this way. So that's why when I try to resolve this, then it becomes here, right? So that's why for this answer, then I will need to minus. Okay, so that's the idea of it. So you just use your calculator and you will be able to solve it and you'll get 102.7. Let me just write 4. Okay, and also your final answer is 103 Newton in 3 significant figure. Okay, so as simple as that, then this is how you get your answer for 1. Okay, number 2, find the magnitude and the direction for the resultant force that exerted by the two people. Okay, so which means just now you already get the component for x. So now we need to find the component of y so that we can find the resultant force. Okay, so this is 2. So same thing, let's try to do resultant for y. Okay, it will be the same thing. So by having this, then you can imagine that when you try to resolve it, right? So for the 60, it will eventually go up. So for the 50, it will eventually go down because for this one, it's basically here and here. So it forms a force in between, right? So you can imagine that if let's say you are using this one, then it should be positive minus negative lah. If you are using going down, then this will be positive and you are using minusing this one. Okay, so yeah, we can just use, so one of the easiest way to do it is that you just always do to the right and to the up lah. So basically it didn't affect your answer. Okay, later I show you the part what's the difference if let's say you use different direction for positive and negative. Okay, so this is maybe we try to do going up. Okay, so if let's say it's going up, so meaning going up the result, the resolve here will be 60 sine 25, right? So 60 sine 25. And then for the other one, it's going to be 50 sine 15. But this is in opposite direction, so that's why we need to minus. Okay, 50 sine 15. Okay, so when you try to solve it, then you will be able to get 12.41961 blah blah blah. And your last answer should be 12.4 Newton. Okay, so this is a part for resolving in the component of y. Okay, so now just a very quick one. I'm going to show you how is that look like if let's say you do different direction. So this is for r, y. If let's say you try to denote that going down is the positive direction. So which means that you are going to do this, right? So this, because going down is a positive direction, so that's why you will actually do 50 sine 15, then going up is opposite direction already, right? So that's why you will minus 60 sine 25. So after you solve this in your calculator, then you are getting negative 12.4. So which means when you try to resolve to y going down, it's negative 12.4. It's actually just the same thing. When you try to change the direction, then this will just become positive. So you see the answer is the same. So it doesn't matter whether which direction that you are using. At the end, you're still going to get the same answer. Because if let's say you get the other direction and you get a negative one, then basically you just opposite the direction, then you negative your answer, then you'll be able to get the exact same answer like this already. Okay, but when we try to find the resultant, we always make sure that our answer is in positive before you do so. So meaning if let's say you do going down and you get this answer, so make sure you try to change to this first before you do your resultant, then it will be easier because we do not want to deal with a negative number. Okay, so now we are doing our resultant here. So by having these two answer, So imagine what happened now is you have your Rx. So let me try to draw it here maybe. Okay, so this is your resultant. This is your resolved component to X. So this one go up is your force that going up, right? Because we are using up, then this is Ry. So this will be our resultant. Am I right? Okay, so that's why to find our resultant here, so what do I need to do? It's just a Pythagoras theorem because it's a right angle triangle, right? So resultant will be equal to, so I try to put in, so make sure that you are typing the long answer instead of like the shorter one. So yeah, if let's say your calculator already doesn't have this value, it's okay. So just try to make sure that you press in at least 3 to 4 decimal places so to make sure that your answer is not that far away from the in terms of the accuracy. So when you try to solve it, then this is how you will actually get 103 Newton. Okay, so in 3 SF as well. Alright, so this is our answer for resultant. So now we need to also find the magnitude and the direction for the resultant. So which means I want to get what is the theta here. Okay, so same thing, I have Ry and Rx, so that's why I can always use tangent to actually solve it. So tangent theta will be equal to my Ry is 12.4161 and then divide by 102.6748. Okay, so by solving tangent and I'll able to get 6.9. Okay, so your angle is always in 1 degree, 1 decimal places. So 6.9. So same thing, you need to indicate where's the direction also. So 6.9 is eventually from the x component, right? So that's why it's 6.9 and it's anti-clockwise from the position. Okay, so at this case, I think a good way to answer is because they give you the direction of the river, right? It's the x direction. So that's why we try to write anti-clockwise from the direction of river. Okay, so after you get your answer, actually you can always like put it back into the situation and you try to think of the, I mean, how logical this is lah. So you see your resultant is like 103, right? Then after that 6.9. So which mean by looking at this, so it's possible because it's like 60 and 50, so the resultant is like 100. Then after that, what happened here is that it's 8.9, right? So that's why you see this is 60 Newton. So it's like pulling harder than this. So eventually the boat will just like the resultant is like somewhere here and this is 8.9. If you get an answer that's like more than 25, then you know something wrong already, or you get lower down, then you also know something wrong already lah. So basically here, then it become 103 Newton. Yeah, so that's the idea that you can try to go back to the question, the diagram that given, then after that you see whether your answer is logic or not. Okay, so yeah, that's the idea. I hope that you can understand. So basically what we try to do is for a force, then we will always resolve it in the two direction that's perpendicular to each other. For example, resolve to x, resolve to y. So after we do this, then we'll be able to actually get a diagram. Then you'll be able to get the resultant by doing Pythagoras theorem. Then also use trigonometry to actually help you to find the direction. So this thing would just be the same if let's say you have more than two forces. So in the next question, we'll be looking at the thing where you involve like 3 or 4 forces. All right, so let's try to move on to the next one. Okay, number 5. So this is also considered like a basic question. So after this number 5, if you think that you are able to actually do it by your own, right? Then for 6 and 7 is like the harder question, but just using the basic skill as well. So if let's say you want to try 6 and 7 by your own, feel free to do so. Then check your answer after that. Okay. So yeah, let's try to look at this question. So this is a question that involved 4 force. So you can see that 4 coplanar forces of magnitude of 4, 8, 12, and 16 act on this point. So the direction in which the forces act are shown in this diagram. So find the magnitude and the direction of the resultant of the 4 forces. Okay, so which means it's the same thing. We are going to resolve it in the x direction, y direction. Then after that, we can find the resultant and also we can find the direction after that. Okay, so now let's try to resolve it to the direction of x first. So similarly, by looking at all this, then you know that the resultant force will eventually going to the right later. So that's why, I mean, it's not, I mean, it's unnecessary if you want to indicate that your left hand side is positive, like you get what I mean, right? Okay, so in this case, so meaning that we are going to resolve it to the direction of x. So same thing, going to the right is my positive direction. Okay, so for me to solve that, this is my 4. So definitely I do not have any, I mean, the 4 is just nice on the component of x, right? So that's why it's just going to be 4 Newton. Okay, and then plus, so this is 8. So resolve to the x, so it's going to be 8 and then cos 30. Okay, because for this sign is touching the 30 here. So that's why the next one, let's try to look at the 16. Sorry, the 12 here. So please remember that can you use 12 cos 30? Yeah, so your angle should be the one that touching until your x here. So that's why it should be 60 in this case. So 12 cos 60. Okay, then the other one is 16. So you can see that 16 is like exactly on the y-axis. So do you think that you need to resolve this? Yeah, so you can try it out and you see later what happens. So this is like 16 cos 90. Okay, so now we can use our calculator to get all the value that we have. So it's going to be 4 and then 4 square root 3 plus 6. And then you will realize that cos 90 actually gives you 0. So we know that as if it's a perpendicular one, right? So that's why when you try to cos the number, it will actually give you 0. So that's why it's not necessary for you to actually do for you to actually write in this part, because you already know that eventually all the forces 16 here will be actually go into the part of the y component. So that's why it's just 0 here. If you didn't write 16 cos 90 here, it will be correct as well. So it's equal to 10 plus 4 square root 3. Okay, then we move on for the next one for the resultant going up. So resultant for y, same thing, is easier for us to do going up since we have 16 here. So that's why we can go this side lah. So 16 and then plus. Okay, so now you see, this is the part where I say make sure that you are very confident with your sign costing, because if not, when you are looking at this 12, right, then you have a problem that you might think whether you should use the 30 here or you should use the 60 here. But from the example 3 that we have just now, right, you know that it's just going to give you the same answer. It's just that whether you want to use cos or sine. If you are using 30, then meaning that you are doing 12 cos 30. If you are doing 60, then which means you are doing 12 sine 60. Okay, so I hope that that clarified. So 12 sine 60. Then after that, plus the 8 also is the same because I want to go here. So that's why I will just use the 30 here. So I will just do 8 sine 30. Okay, so for this case, it's the same thing lah. So for 4, you imagine that later it's going to become 0 as well, because the whole 4 actually going into the component of x already. So that's why you do not need to do anything about that. So it's equal to 16 and then plus 6 square root 3 plus 4. So in the end, you'll be able to get 20 plus 6 square root 3. Okay, I will highly encourage you to leave your answer in cert form first, because you imagine later when you are trying to find your magnitude, if you are doing a rounded number, then yeah, you have high possibility that later you cannot get a very accurate answer. Okay, so similar thing, let's start with the straight line first. Sorry, straight line as if the horizontal line. So from here to here is 10 plus 4 square root 3. Then after that, going up is 20 plus 6 square root 3. Okay, and this is my resultant. Alright, so this is my angle later. Okay, so let's try to find the resultant first by using Pythagoras theorem. So r will be equal to square root. So we can just put in the value. So 10 plus 4 square root 3 square plus 20 plus 6 square root 3 square. Okay, so just by using our calculator, and you'll be able to get 34.8 Newton. So 3SF. All right, then after that, for the last one, you need to find the theta. Yeah, so I mean, you can use all sine, cos, tangent, but r is the one that you find and you rounded this already. So the better one will be still using your OA. So that's why tangent theta is actually equal to opposite is 20 plus 6 square root 3 over the adjacent is 10 plus 4 square root 3. Okay, so by having this, solve the trigonometry, then you can get 60.9. Okay, so same thing, you need to indicate that where is the 60.9. So same thing, the question didn't give you the components, so make sure that you answer according to the diagram given. So it's going to be 60.9 from anti-clockwise from the direction of 4 Newton. Okay, so 60.9 anti-clockwise from the direction of force for Newton. Okay, so yeah, that's the idea how you should answer. Then, I mean, of course, if you want to say like this, then you can try to do the other side, which you will get like, for example, it's like 61. So that's why it's like 29 clockwise from the direction of the force of 16 is also the same thing lah. Okay, but if let's say for Pythagoras theorem, we try to draw like this, then it will just be easier if we always try to answer it based on the diagram that's given. Okay, so yeah, just like that for the part one, I hope that you are very familiar with the part where how do you resolve, then how do you combine the resolve and you get the resultant, then after that to find the direction already. Okay, so now this number two. So the forces of the magnitude 4 Newton and 16 Newton change their direction, and the forces of the Newton, 8 Newton and 12 Newton also have changed their direction. So what happened here is you can see that this is 4, 8, 12, 16. So 4 and 16 exchange, then 8 and 12 exchange. So this is what you get lah. Okay, so the question wants us to state the magnitude and the direction of the resultant for the four forces. So the question used the word state. So that's why they don't actually expect you to recalculate everything. So there should be a shortcut way for your, based on your understanding, then you should be able to actually answer this question. So I'll try to explain it like this so you can try to see that the whole diagram here is actually just like uh so what happened is like here and here change and here change, because all this angle is actually the same, right? So you can imagine if let's say after all this then it resolved to here, it gives you 10 plus 4 square root 3. So which means now it's going to be resolved in this direction. So what happened here is that our part for the side here is actually going to be rotate. Okay, you get what I mean? Okay, let me try to write down. So this one is what I get after I resolve like from 16, 12, 8 to the direction for 4. Then I get 10.4 square root 3, right? Then isn't it I try to do the same thing? I resolve everything to the direction of 4. So that's why for this part, I'm going to get 10 plus 4 square root 3. Then after that, for this part, I'm trying to resolve everything to the direction of 16, and that gives me 20 plus 6 square root 3. So that's why it's the same thing, right? 4, 8, 12, 16. So to the direction of 16 here, so which will give me the same thing, which is 20 plus 6 square root 3. So that's why by using this diagram, you'll be able to see that actually what happened is these two just exchange with each other. So that's why my magnitude is just going to be exactly the same. Okay, so yeah, because by using Pythagoras theorem, it's just give you the same answer, right? So you can straight away state your answer here. Then the other one is the direction for the resultant. So you can imagine that it's going to be different because this is a larger force, then this is a smaller force. So that's why you can imagine that this angle will be higher. You get what I mean? Because this is okay. If let me try to explain it in the form of if this length is shorter, right? Because the force is shorter, because the force is smaller, then this force is larger. So that's why the line is larger. So that's why when you try to draw this, then eventually this angle will become larger. So, but here is that it is in opposite way already. So this is longer, then after that this becomes shorter. So you can see that the angle will definitely be different when you try to compare to this. Okay, so what's the relationship between them? It's actually just 90 minus. Okay, so the first way is you can straight away use theta equal to 90 minus your answer in previous, or I think there's nothing wrong also if you try to recalculate it. So which means you just try to do tangent theta, and you already know these two things is going to be opposite and adjacent, right? So that's why 10 plus 4 square root 3 then divide by 20 plus 6 square root 3. Yeah, so that's why by solving this, then you'll be able to get 29.1, which is exactly 90 minus 60.9. Okay, so same thing, this is the anti-clockwise from 16 Newton. Yeah, I don't write the whole thing lah, from the direction of 16 Newton. Okay, so yeah, that's the idea how you should answer this. Okay, so right, let's try to move on to the next two questions, which is slightly different than these two questions, but the basic is just the same. Alright, so for number 6, when we look at this diagram, then we realize that something different lah. For example, that's given this alpha and they didn't tell you what's the alpha. Then for example, it also there is a negative direction involved. So for example, if let's say going up and going right is your positive direction, then you'll realize that when you try to resolve the 30, right, you will have a direction that is going to the left and going to the down as well. Okay, so that's why these are the few things that you need to be careful of when you try to do this question. Okay, so yeah, so you have these three coplanar forces. So 50, 40, and 30 add on the point O in the direction shown in the diagram, which tangent alpha is equal to 7 over 24. Okay, so perhaps let us try to solve out the alpha first. So actually you have two ways to do that. The first one is you straight away find what's your alpha. But in that case, I don't actually recommend much you to actually go onto that way, because if they want you to do that, then which means this question might as well just give you the alpha. You get what I mean? I mean, for these tables, there's no initiative why they want to test you on how to find alpha. So that's why in this case, it will be good for us to keep tangent alpha, but we can actually find out our cos alpha and our sine alpha. So how can we do that? So we can try to just draw a diagram to draw a right angle triangle to help us to solve it. So you can imagine if let's say now my alpha is like in this way. So yeah, it actually doesn't matter how I draw it. For example, if let's say I just want to follow. So this is a triangle that I would have, right? So this is my alpha. So you can imagine if it's equal to 7 over 24, we don't okay, so I'm not saying that the length is exactly 7 over 24, but eventually after I get my answer, after I simplify, I'll just get the same thing, so it doesn't matter. So opposite and adjacent, so from here then I know that this is going to be 7 and 24. Okay, so by using Pythagoras theorem, then I will be able to get that my hypotenuse is just going to be 25. So that's why by having this, actually I already know that what is my sine alpha and what is my cos alpha. So which means I do not need to know exactly what alpha is. So sine alpha is going to be opposite over hypotenuse, so 7 over 25. Then after that, my cos alpha is going to be a over h, right? So that's why 25 over 24. So this is how I get my sine cos from this information. So now I can just move on to find the magnitude and the direction for the resultant force. So the same thing we need to do to the x direction and to the y direction. So how can we do that exactly? So let's start with fx first. So we denote that to the right hand side is positive lah. Okay, so in this case, we have 40 here. So I think this is easy. So just 40, then you are going to cos alpha. So 40 cos alpha. Okay, so now you have a problem. So you know that 30 will be kind of resolving here as well, right? So after you resolve 30, it should be 1 going here and 1 going down. Okay, so what is the issue that we have here is that I do not know what is the angle here or what is the angle here. So how am I going to find that? Okay, so we will need some trigonometry knowledge that you have learned previously. So let me try to do this better. So yeah, this is the line, right, going down. Okay, can you try to imagine if let's say this is alpha and this is 90 degree, then what is this? So let me try to say this, then when I try to draw this going down, right, isn't it mean that here is going to be 90 as well? So you can try to imagine if my alpha is 10 then what is this? So it's going to be 10, then 80, right? So if this is going to be my 90 degree, then 90 degree minus 80, what do I get? I get 10 also. So it's the same thing. If let's say this is 20, this is 60. So this is 20, this is 70. So I try to do 90 minus 70, then I get 20 also, which is the same with alpha. So from here, then we know that this is going to be alpha as well. Okay. So yeah, it's like a understanding question. So you might do, I mean, to get this point is alpha is like an understanding part. So you wouldn't really need to write down the working for this. So, but you will just show your working that you understand this is alpha by your working, that you use it to resolve. Okay, so now we have this is alpha already and this is 30, right? This is what I want to get again. So please remember you are finding this part. So that's why when your alpha is inside here, which means this line is not touching your alpha. So you should use a sign. So that's why this is in opposite direction than my sorry, this is in the opposite direction when I try to compare my right hand side as positive. So that's why I will try to do minus and then 30 sine theta alpha. I'm sorry. Okay. So I hope that you get what I mean because this is alpha. So because if let's say I'm finding this line, then I will using 30 cos alpha. But I'm finding this line, which means it's not touches my alpha. So that's why I should use sine instead. So why is it minus? Is because of after I resolve it, then it will eventually go to here. So that's why it's opposite of my positive direction. So that's why I will need to do minus. Okay, so after I do this, then I can substitute the number that I have over here already. So equal to 40. So my cos alpha is 24 over 25. And then minus 30. So sine alpha is 7 over 25. Okay, so by using calculator, and you'll be able to get exactly 30 Newton. All right, so now same thing. Let's try to do resolving for y. So we try to do going up lah, going up, or okay, maybe going down lah in this case, since we already know that this 2 is going down, right? So if let's say we get a negative also, that's all right. We can always change it back to positive. Okay. Oh yeah, just now we didn't do the 50 is because of 50 is exactly on y. So that's why you already know that cos 90 will give you 0. So you don't need to add in the 50 just now for the x component. Okay, so for the 50 here, so we know that now if let's say we try to do going down, so which means that we can always start from 40 and 30 first. So for 40 is going to be 40 and then sine alpha. And then for this one is going to be plus. So this 2 is positive because now going down is our positive direction. So that's why plus 40. So what I have here is 30 cos alpha. Okay, because it touches 30. Okay, so now then I can just continue. So 40, I'm sorry, we didn't finish yet. So this is going down for the 30 and 40, and don't forget you have 150 going up. So that's why 50 is in the opposite direction of going down. So that's why minus 50. Okay, so let's try to solve this. Then I'll be able to get 40 sine is 7 over 25. And then plus 30 cos 24 over 25. Yeah, we might get a negative answer by looking at the number that we have here. I don't think we have a number that's greater than 50. So yeah, when you try to press your calculator, you'll be able to get negative 10. Okay, so what happens if you get negative 10? So don't worry, you just change your sign. So meaning that when you try to change it to positive, then you change your sign. Then this one will become positive lah. So just like that. So don't worry about which is the sign that you denote at the first. Okay, so after we do this, then now we can try to find our resultant already. So it's the same thing. It's going like this. Then after that, going up. Okay, then this is my resultant. Sorry, it's a bit ugly. Okay, so yeah, do like this. Yes. Oops, I'm sorry, I think I used F here. Yeah, don't worry, if you use F, then as if like force resolve to, yeah. So I think when you look at books, sometimes they use F. When you look at the puzzle questions, sometimes they use R, or sometimes they use like a different notation as well. I think that's fine. So as long as you know that what you are doing lah, because R meaning you resolve to where, then if F, then you can explain it as is the force in the direction of X. Yeah. Okay, so but here then we try to use resultant for a better course, I guess. So 30 square plus 10 square. Okay, so you just solve it, then you'll be able to get 10 square root 10. So if you want your answer in decimal, then it's 31.6 Newton in 3SF. Okay, so after you have get this, then we need to find our degree here. All right, so tangent theta also. So my opposite will be 10 and this is 30. So that's why 10 over 30, which is 1 over 3 lah. So from here, then I get my theta is 18.4. Okay, so same thing in this case is already given that it's x direction. So that's why I can just answer is 18.4 anti-clockwise. Okay, from positive x-axis. Yeah, so you will actually have a clockwise thing if let's say you imagine if let's say the going down just now, if we get a positive value, right, then what happened is your resultant is like going down. So that's why your answer will be how much then going clockwise lah. So because this answer is like going up then going to the right, right? So our resultant is like this. So that's why this is why our angle is like anti-clockwise from the positive x-axis. Okay, so now number two. Yeah, so this is a one question. So normally we know that this question is like the critical thinking part, which you do not need to really do any calculation. It's from your understanding and you try to get the answer. So the force of the magnitude of 50 is replaced by a force of magnitude P. So which means here, okay, it's going to be replaced by P Newton acting in the same direction here lah. Okay, so the resultant of the three forces is now exactly here already. So they want us to find what is the value of the P here. Okay, so what does that mean? It means that if let's say all my, so you can imagine, right, in what scenario that my resultant will be exactly here, is that if I do not have any y here. You get what I mean? So for an example, if let's say I have just 1 Newton, then if let's say I have only 1 Newton, right, the resultant also will be a little bit higher. If I have 1 Newton going down also, it will be a little bit lower. So that's why it wouldn't be, if there is any component for x, right, then your answer, your resultant wouldn't be exactly on this positive x direction. But if let's say it's on the positive x direction, what does that mean? It means that you do not have the component for your y, the force for your y is basically 0. Okay, so that it wouldn't form any resultant except, out from the positive x-axis, right? So that's why in this case, it means that when we try to look at this, then you'll be able to see that this part, when you try to minus 50, then you get negative 10. So now you want to get your resultant, you want to get your component y as 0, right? So what is the value that you minus and you will get 0? So is that you want to use 50 to minus out the 10 that extra that you have, right? So that's why for this case, your P here is just going to be 50 minus 40. 50 minus the extra 10 you have. So that's why it's 40 Newton. Okay, so the idea is for the previously, your Fy going up is 10. So I don't want the 10, right? So that I do not have extra forces that actually cause a resultant at here. So now I want my resultant to be only on my positive x direction. So that's why I need to make sure that my y is 0 lor. So for me to get my y 0, then I need to eliminate this extra 10. So by using that, if going up give me, so if I have extra 10 over here, so which means I do not want to have 50 so much, I only want to have 40. So that's why I have going down is like 40, going up is like 40, then I have 0 here. Okay, so this is like the idea that I want to do. So I try to make this equal to 0. Okay, so this is how I get to this answer. But it's just 1 mark, so basically it's just like 50 minus 10, or even you just write your answer 40, and I think that's correct as well. Okay, all right, so now let's try to look at the last question. All right, so the last question here, so you'll realize that I only put in the part 1 for this question because part 2 involving some formula that we haven't learned yet. So that's why I'm just putting in part 1 because I guess it's a pretty interesting question. and you can see like a different approach that how they ask question about the force and equilibrium. Okay, so right, let's start with the question. So a small bit Q can move freely along a smooth horizontal straight line AB of length of 3 meter. I don't think you need this information lah because you are not doing the part 2. So three horizontal forces of the magnitude of F and then 10 and also 20 add on the beat in the direction shown in the diagram. So the magnitude of the resultant is shown here with R, and after that the direction is 15. Okay, so right, we need to find out the F and the R. So you see that this question is a bit different than the previous one, is that even for the applied force, right, you have one that is unknown, which is the F here. So which means we cannot use the normal approach that we do, which is to find the component in X, Y, then after that find the resultant, then we get the direction and so on. Okay, because that's an unknown here. So meaning that by looking at this question, you have two variables, which means you are going to do something similar like simultaneous equation to get like two equations for you to actually solve this question. Okay, so how are we going to do that? Let's do the normal approach, like how we find out the component in the direction of X first. Okay, so the direction, so resolving it to X, so same thing, we try to make our positive as to the right hand side. So what we have here is definitely 20, okay, equal to 20. And then to the power of F here, so I have plus F cos 70. Okay, so yeah, remember that you cannot add in, so this is the resultant, so please do not add like R cos 15 here. So another one is the 10 here, so this one after you resolve, it will be 1 going to this direction and 1 going down, right? So that's why it's opposite than the direction that you indicate before, so that's why it's going to be minus, and then 10 cos 30. Okay, so now you realize that we don't have any variable that is using R yet. So that's why how are we going to connect our R with our Rx here? So if this is my resultant force, do you think I can resolve my resultant force? So when I resolve my resultant force again, right, isn't it I'm getting back the resolved component that I have? So that's why for Rx is actually just the same thing when I try to do R cos 50. Okay, so I hope that you can get the idea. Yeah, so 20 plus F cos 70 minus 10 cos 30. So for now, we try not to simplify anything first up because I think cos 30 is still okay. You should be able to get an exact value in third form. But in these two cases, for cos 15 and cos 70, we try to leave our answer here. So that's why for us to substitute in another equation later, we can try to arrange it first. So I will have 20 plus F cos 70. So since this one you can simplify, so depends on you whether you want to simplify or not. Yeah, it's just going to be the same at the end because it's a calculator that going to do it for you. So cos 15. Okay, so this will become our first equation. So now I'm going to do the exactly same thing for the y direction. So resolve y. So I'm going to move going, yeah. So for this, you can see that R is resolved to the right and going down. So that's why it will be easier for us to annotate that going down is positive. If not, later you will need to change it to negative. But yeah, it's just the same thing like at the end. So you can try to do going down. So that's why in this case, then what do I have? So this is my 10, right? So it's going to be 10 sine 30. Okay, so since going down is positive, so that's why I don't need to put negative here. Then the other one, this is going to be negative now. So 70 will be resolved going up and going here, right? So F sine 70, but it's minus F sine 70. Okay, is that all right? Yeah, so just by doing so, then I'll be able, yeah, here. So the same thing here. So this is my resultant. So when I try to resolve my resultant, then I can eventually get back the component as well. So that's why it's 15 is R sine 15. Okay, so equal to 10 cos 30 minus F sine 70. So this is my second equation. So I think the similar thing, sine 30, if you want to change it first, you can try to change also because sine 30 will give you half, I think. Yeah. If you are not going to do that, it's just going to be the same thing at the end. So yeah, so we try to substitute number one going into number two. So you can imagine that you are going to have a quite long equation. So yeah, for this one, I'm going to fast track everything because I feel maybe you'll feel a bit difficult at the beginning, like how are you going to simplify everything here? But eventually it's just like simultaneous equation. So I will just show my working here. So I think because I think you can definitely understand, it's just that it's your first time, so that's why it feel confusing. And yeah, because I'll spend a lot of time in writing, so that's why I think I can fast track the video. All right, so yeah, this is how I get to my answer 1.90. Okay, so yeah, that would be our answer. So you can just try to write out like few numbers if you want. So yeah, that's F. Okay, so basically you just bring everything go over to the other side and then become divide. So 1.901924 and so on. So in three significant figure, then it will be 1.90. Make sure you write the zero to indicate that you are doing 3SF. Okay, so after you have do this, then you actually get your F ready. So it's just now we use a random R1 to get our F. So it will be easier for us to use just the number one. So R will be equal to 20 plus. So remember the F that you are putting in is the original number. So you're just going to press it like press your answer then cos 70. Okay, then minus 10 cos 30 over, sorry, it's a bit ugly. So 50. All right. So yeah, after you press it, then you'll be able to get 12.4 Newton in 3SF also. Okay, so this is how you solve this question. Okay, so now I will show you the second approach. I'm not going to go through the whole thing again with you, but I am just show you that this is another possible way that you can try to do. So it's the same thing like how you started. So, but then we don't substitute the Rx part. So which means I will have Rx then to the right. Then I do my calculation. Then for example, if let's say I get A lah, okay, then after that what happened here is same thing, I do my vertical component. So in this case I'll do going down as well. So from here then I'll be able to get my B. So after I do this, right, then how do I form my two equation? Because eventually you can think that what I have is just basically this and also this, am I right? But after that, how am I going to continue is that I use the other formula to actually connect them together. So how can Rx and Ry combine together is by using Pythagoras in R. So that's why after I have these two, then I have R is equal to square root for Rx square plus Ry square. Am I right? So that's why I'm going to use these two, then this is my second one, right? Third one, so that's why I'm going to use my first one plus my second one and then I substitute into my third one. So you can imagine that now I have my R and I have my F in my equation already. So this comes to my equation of 4 and this is the equation that I want to use later. So, but you'll realize that I only have one because I have R here, then here is the part where I have my F. So how am I going to have another one is by using the direction because we are given this 15. Okay, so that's why we also know that the tangent 15 is actually going to be equal to the opposite over the adjacent, right? So which means in this case, then it will be the B over the A. Okay, so same thing, you're kind of, this is your number 5. Okay, so you are going to substitute your 1 and 2 inside your number 5. So you are going to get your number 6 equation. So these are the two equations that you are going to solve. Okay, so eventually from here, then you're having your F also lah. So this is how you can actually solve it. And I think if let's say you try to use this method, then maybe you can actually solve your this part first, because for your 5, right, after you put in your 1 2 into 5, actually for the number 6 one it's not simultaneous already, because you only have the F. So you can try and see whether you can solve this one first, then after you get this one, then you use your number 6 answer to help you to solve number 4. But that's the other idea that you can do this question lah. Yeah. Alright, so I hope that you are okay with this chapter. So yeah, if you have any question, then please let me know personally as well. So yeah, spend some time to do your work and so on. And next week we'll move on discussing about the same part but in a form of forces in equilibrium. Alright, so that's it for today's session. Thank you.